Video 3, question 114. If tx is q times 3 to the x plus 1, what is the value of t at minus 8? Now you can see there the graph has been given, or a part of the graph of t has been given. That's very important. It's also very important to take note that, as you see here, this is an exponential function. Now the very first thing we're going to do, just to make it friendlier for us, we're going to do an extension to the y-axis and also to the x-axis, just to make it a little bit more friendly. And then we're going to take note of a very important part of this exponential function, and that is the constant that you see there at the end, that 1. Now, that 1 represents the asymptote of this particular exponential function. And so the asymptote is going to be graphically, it's going to be a line that is horizontal. It sits about there, and the value of that intercept on the y-axis is 1. So this is the line y is equal to 1. Y is equal to 1 is the equation of the asymptote of this particular graph. I'm just going to make the graph a little bit longer. Let's do that. The graph of t, and here sits the graph. And so let's draw it a little bit longer. It's going to look like that. And you can see that for us to find the y value that corresponds to an x value of 8, if we say that negative 8 is approximately there, then it's quite clear to see that if you look for the y coordinate corresponding to the x coordinate minus 8, that y coordinate is very close to the white line, y is equal to 1. And so the y coordinate would have to be very close to positive 1. And the only value that is close to positive 1 is d. And so that's the correct answer. Really, how we've done this problem is we've used knowledge of the exponential graph, in particular the value of the asymptote, and also a little bit of logic, something of which you have a lot of. And so I hope that you have learned. Let's move right on to the next question. What you see here is question 117. Determine the total surface area of a right triangular pyramid. All the edges are 2 units. Now the first thing you do is to sketch this. It doesn't have to be very neat, as long as you can see what you are doing, and it's going to help to draw the sketch. And let me do it right here in your presence. So there you can see a right triangular pyramid. All edges are 2 units long. Let's go add that. So that's 2 and 2 and 2 and 2 and 2 and 2. I think you can see the picture quite clearly there. Now we want the total surface area. It says determine the total surface area. And so for us to find the surface area, we're going to have to do something very interesting. We're going to have to take this 3D and sketch a 2D that represents that 3D, and that would be called the net of this pyramid. So we're going to unfold the pyramid, and let's do that. So if you unfold the pyramid, you can imagine that you have a triangle at the bottom that would be like the floor of a tent, and then you have the three sides, or the 3 flaps that make up the tent, and so that would be another 3 triangles, and then you have the net representing the pyramid. And so the net is such, remember that it said that the edges are all the same, the edges are all 2. And so really what we have here is 1, 2, 3, 4 triangles, and all the sides of all 4 triangles are equal, and therefore the triangles would definitely be congruent. And I hope you can remember from the past one of the congruency cases called side, side, side. So these triangles are congruent, and for us to find the total surface area, all we need to do is we need to find the area of one of the 4 triangles and multiply that by 4. So if you redraw this triangle, let's make it a little bit bigger. If we make it a little bit bigger, there we go. Let's say that's one of the sides, and that's the second and the third side. Remember that these sides are all 2 units. And because they are all 2 units, it means that this is an so-called equilateral triangle. It's an equilateral triangle, and therefore the angles are all 60 degrees. And the easiest way for us to find the area of the triangle is simply to say area of triangle is equal to a half times A times B times the sine of C. That is, and if you go back to the triangle, that is a half times 2 times 2 times the sine of 60. And all we do now is we simply simplify this. A half times 2 times 2 is a half times 4, which is 2. Sine of 60 is square root 3 over 2. That you need your special diagrams for. 2 divides into 2, so we get square root of 3. Now remember, this is the area of one of these triangles. And so the area of all 4 would be 4 times that. So it is 4 times the square root of 3. And 4 times the square root of 3 would be the area of all 4 triangles, which is the total surface area. And there you can see is the answer. Well done to you. We're going to move on to the next video.